In 7.4, we're going to use matrices with our systems of equations. And in this section, we're going to learn how to write matrices and identify their dimensions, and then also perform elementary row operations with the matrices. We'll look at different techniques where we can use matrices to help us solve systems of equations. And that technique involves the use of a rectangular array, which a rectangular array is really just a matrix. So the definition of a matrix is if you have m and n are positive, then m by n is your matrix. So rows are always across. So if you notice, your rows are always horizontal and your columns are always vertical. So when we're looking at a matrix, if they say, A sub ij or A sub 2, 3, then that means that you're looking at the entry that's in the second row and the third column. So that subscript is really just giving you what particular entry you're looking for. And the dimensions of a matrix are always m by n. So it's always row by column, not column by row. So if we look at this first example, and we're just determining the dimensions of each matrix. And to determine your dimensions, you just count the number of rows and the number of columns. So in our first matrix, we have one row and one column, so we would say the dimensions are 1 by 1. In part B, we have one row and 4 columns, so the dimensions would be 1 by 4. In C, we have 2 rows and 2 columns, so we have a 2 by 2 matrix. In D, we have 3 rows and 2 columns. And in E, we have 3 rows and 1 column. So remember, you just write for your dimensions. Your dimensions are always row by column. So if you have a matrix that only has one row, like an example B or 1B, so if we look back here where we just have one row, that's called a row matrix. So we could add to this that this is a row matrix. And a matrix that only has one column would be a column matrix. So this one would be a column matrix. And that's just some vocabulary for you as you go through the section. And then if we have a matrix that comes from a system of linear equations, each written in standard form, then we would have an augmented matrix. So the augmented matrix uses the coefficients from your linear equations and your solutions. So augmented uses coefficients and solution, where a coefficient matrix will only use the coefficients. And so if you look at this as kind of an example of what the difference is, so if this is our system of equations up here, the x minus 4y plus 3z equals 5, for the augmented matrix, we would take the coefficients from each of the terms, so the 1, -4, 3, and then we have this little dotted line that goes down vertically, and we put what it equals on the other side. It equals 5. And we do that for each equation that you have. So when you have all the coefficients and you have the solutions, that's an augmented matrix. If you just write the coefficients without that 5, -3, and 6, that's called a coefficient matrix. So for this example, we need to write an augmented matrix for the system of linear equations. So remember, an augmented matrix includes all of the coefficients and the solutions. And if you notice here, we have x, y's, and z's. So when we're writing our matrix, we probably want to have columns for x, y's, and z's. So for our first equation here, we have 1x, 3y, 0z. You have your dotted line, and then it equals 9. For the next equation, you have 0x, -1y, 4z, and it equals negative 2. And then for your last equation, you have 1x, 0y, negative 5z, and it equals 0. And then the second part of the question is what are the dimensions? So if you count, we have 3 rows and 4 columns. So the next thing we're going to talk about is the row echelon and reduced row echelon form. And we're really just going to focus on the reduced row echelon form, because what happens is we can take our matrix from augmented form, which remember was this right here, and we can use our calculators to get it into reduced row echelon form, which actually will solve our system of equations for us. So here, if we want to solve the system of equations using reduced row echelon form, the first thing we need to do is write our augmented matrix. So in our first equation, we have 0x, 1y, 1z, and negative 2w, and it equals negative 3. In our next equation, we have 1x, 2y, negative 1z, 0w, and it equals 2. Then we have 2x, 4y, 1z, negative 3w, and it equals negative 2. And then our last equation, we have 1x, negative 4y, negative 7z, negative 1w, and it equals negative 19. So from here in your calculators, so I need you to turn your calculator on. And if you look at the left-hand column right above the x to the negative 1, you'll see matrix. So hit second, x to the negative 1, and you'll get the screen that says Names Math Edit. Go over to Edit and hit Enter. And so now you'll be on a screen that will say Matrix A, and it'll be 1 by 1. But here we need to set our dimensions. So remember the dimensions of this matrix are 4 by 5. So in your calculator, set your dimensions as 4 by 5. And then what happens is your calculator actually gives you a screen where you can fill in all of the values. So go ahead and press pause and take a minute and fill in all of the values from your augmented matrix into your calculator. Okay, so now at this point on your calculator screen, you should have gone through your second x to the negative 1, which gets you to the matrix. Go to Edit, change the dimensions to 4 by 5, and you filled in the matrix. So now what you're going to do is go back into your matrix. And once you go back into your matrix, go over to your math and scroll down, mine's letter B, till you get to RREF. It's right below REF. So it'll say RREF, and then it'll have a parenthesis. And hit Enter. And then from there, you're going to go back into your matrix. So you go back into your x negative 1 matrix and choose matrix A. All right, and so then we're going to choose matrix A. And you choose that just by hitting Enter on your matrix A. One thing I think I forgot to mention is after you fill in your matrix here and before you go into your second matrix again, go back to your home screen, because you don't want to be doing the RREF or the reduced row echelon form in your matrix. So if you're in your home screen, you want to be doing this on your home screen. And so then you chose matrix A, and then you hit Enter, and you get this new matrix that looks like this. It's 1, and then we have 3 zeros, and then a negative 1, and then 0, 1, 0, 0, 2, and then 0, 0, 1, 0, 1, 0, 0, 0, 1, and 3. And what this is this is your reduced row echelon form. So remember that this column was your X, your Y, your Z, and your W. So if we were reading this, we would say that there's one X and it equals negative 1. So we would get X is negative 1, and then there's one Y and it equals 2. There's 1z and it equals 1. And then there's 1w and it equals 3. So that would actually be the solution to that system of equations that we had here in the beginning.